All right, so today we are going to learn about a mathematical object called vectors. Okay, so let me illustrate this. Okay, so let me tell you something. So I'm driving at 50 miles an hour. Okay, that's one fact. I'm driving at 50 miles an hour north. What's the difference?
The direction.
Direction. So there's more information there. Okay, so the first quantity is called speed. The second quantity is called a velocity. Okay, so in physics we have quantities that can be described by one number, and those things are called scalars. And then there are quantities that have to be described using more than one number, and those can be, so some of them are vectors. Okay, so you need more than one numbers to describe them. So scalars are quantities such as speed, pressure, temperature, energy, and so on. Okay. All these guys are scalars, and all you need is one number to specify them. Okay. Then there are quantities such as velocity, force, acceleration, momentum, linear momentum, and so on, that need more than one number to specify them. Okay, so how many numbers do you need to specify velocity? More than one. How many? Two. Any other answers? Okay, so it depends on how many dimensions you are in. Okay, so in 3 dimensions, you need 3 numbers to specify velocity. You need 3 numbers to specify a vector. Okay. If you happen to live in n dimensions, how many numbers would you need to specify a vector? N numbers. Okay. Yeah. Okay, so what did we learn? These vectors have magnitude and direction to them. Okay, so what does that mean? If you're living in 3 dimensions, you need 1 number to specify the magnitude and 2 numbers to specify the direction. Okay. If you live in n dimensions, you need 1 number to specify the magnitude and minus 1 number to specify the direction. Okay. So let me illustrate that to you. Okay, so let's say we live in 3 dimensions, x, y, z. Okay. And so here's a vector. Okay. So the magnitude is given by the length of the vector, and the length of the vector would be the same no matter how many dimensions. The dimensions wouldn't affect the length of the vector. And the direction would be given by these 2 angles, for instance, in 3 dimensions. Okay. You can, here's one way of specifying them. Here in physics, we call this angle theta. And then in the projection of this vector on the xy plane. And this would be the other angle to specify the direction. Okay. All right. So in this chapter, what we're going to learn about is we're going to learn about vectors. Okay. And vectors are mathematical objects that are used to describe quantities such as velocity, acceleration, forces, and so on. Okay. Yep.
So in this class, we use z as the up direction.
Yep. Mm-hmm. What we use is a right-handed coordinate system, x, y, z. So here's your right hand, x, y, z. Okay, or x, y, z. You can point them any which way you want. Okay, and the way this thing is, when you turn x to y, if you turn the screw this way, the screw would move that way, and that would move in the z direction. Okay, so you can choose. So everything we do will be with respect to a right-handed coordinate system. Do you still have your question? Okay. All right, so today we are going to learn about this mathematical object, vectors. Yeah. Now, when you first learned about numbers, what did you learn to do with numbers? I'm sorry? Okay. Count, add, subtract, multiply. Okay, so that's how you get to know a mathematical object. And that's what we're going to do today. Okay? So we're going to learn about vectors. We're going to learn how to add them, subtract them, multiply them. That's the chapter. Okay? All right. Everybody understand where we're going? All right. All right, so vectors are quantities that have magnitude and direction, and you can use arrows to represent them. Okay? And here's the notation. Okay, so you use either capital or lowercase letters, and to specify that it's a vector, you draw an arrow on top of it. Okay? So here's a vector A, this is D, B, C. Okay? All right, so vectors are denoted like that. This, when you write absolute value sign around them, that this thing indicates the magnitude of the vector. Okay? So that's telling you the length of the vector. So that's the notation. Okay? So scalars are quantities that have only magnitudes, and vectors have both magnitude and direction. Okay? And again, how many numbers do you need to specify the direction of the vector? I'm sorry?
More than one.
More than one. N minus 1 numbers, okay, in n dimensions. Okay, so here is a physical quantity, a displacement vector. Okay, what is a displacement vector? Let's say you start at point A and you go to point B. Okay, so if you go along this path, your displacement vector is a straight line vector from A to B. If you walked along this path, your displacement vector is the same. Okay. So how many different paths are there for which the displacement vector is that? Infinite. Okay. So the displacement vector is a vector that points from your initial point to your final point. It doesn't matter what path you take. Okay. So let's say you go for a walk and you come back home. What's your displacement vector?
0.
Okay. So it's the 0 vector. This guy is not the same as the 0 number. Okay. You learn this, so I guess, so we'll give it a name. And when we write the components of the vector, so this is 0i, 0j plus 0k. Okay, all components are 0. Okay, and we'll learn what that means in a bit. Okay, so here's your first vector, the displacement vector. Okay, the displacement vector is a vector that points from your initial point to the final point. Okay, and it doesn't matter how many dimensions you're talking about. Okay. So in 3 dimensions, for instance, if you go on a flight, the displacement vector will point from your starting point to your end point. Okay? You guys following this? All right. So here's a vector A, and this is 2A. All right, let's look at this carefully. 2 is a scalar, it's a number. And A is a vector. So you multiply 2 different kinds of mathematical objects. You multiplied a scalar times a vector. Do you know what that is? You all know that intuitively. It's a vector twice as long. Okay? So that scalar multiplied the magnitude of the vector. Okay? So that's 2A is that. And you also understand minus 2A. 2A minus 2A is twice as long, except that pointing in the opposite direction. Okay? So in fact, what you've learned is this was 2A. You've learned 2 things. And minus of a vector is a vector pointing in the opposite direction. Okay? So what you've learned is how to multiply a scalar to a vector, and you also have learned what the negative of a vector means. Okay? All right, so here is the deal with vectors. Two vectors are equal to each other as long as their magnitudes are equal and their directions are the same. Okay? So it doesn't matter where you draw the vectors. Okay? So for instance, you are driving at 50 miles an hour north in Daytona Beach or in San Francisco. Your velocity is the same, assuming the earth is flat, but we won't get into nitpicking that, all right? So, all right, so two vectors are equal to each other as long as their magnitudes are the same and their directions are the same. Yep. All right, so here's the first operation. We'll learn how to add vectors. Okay, so here are two vectors. Okay, and remember, you can move this vector parallel to itself and draw it anywhere, because this vector is equal to that vector, because that has the same magnitude as that, and that's pointing in the same direction as that. Okay, so when you want to add these two vectors, here's the procedure. Here's the first vector. You draw the tail of the second vector on the head of the first vector. There's the second vector. And the sum is from the tail of the first to the tail of the second. Yeah, that's how you add it. So here's how you add vectors, and that's shown graphically. Okay? Now this is a good picture to have in mind, but this is not a practical way to add vectors. We'll show you the algebraic way of adding vectors. Yeah, we'll show that to you in a second. But that's how you add vectors. All right. So you learned how to add 3 plus 4. Can you add 5 to that? You know how to do that, right? Same thing with vectors. I added a plus b. I can add c to it, d to it, e to it. Okay, so the procedure is the same. Here's a, b, c, d, e. Okay, and the sum of all those is this vector. Okay. So how many vectors can you add together? Infinite. Okay. So now you've learned how to add vectors. Do you also know how to do this? Do you know how to do that? Yeah. Because you know what minus of a vector means. Okay. Subtracting a vector is the same as just adding the negative of a vector. Okay. Did you guys understand that? So now you know vector addition and subtraction. Okay. Now we'll have to learn how to multiply vectors, but we'll have to build towards that. Okay, so we'll get to that in a second. Go ahead.
I guess I'm not entirely sure actually, because I thought a negative vector is just the vector in reverse, right?
Right.
So
you give it another name. We'll call it SAN or S. And now you know how to add A plus S, right?
yeah.
There you go. All right. Now, again, whenever you're doing operations with a new object, you want to learn you want to learn the basic properties. You know that 3 plus 4 is equal to 4 plus 3, right? So this property is known as the commutative law for the addition operation. This is true for numbers, and so you ask, is that true for vectors as well, for vector addition? and it is true for vector addition as well, okay? So here is A plus B, which is C, and this is B plus A, which also turns out to be C, okay? So this property is true for vector addition. The associative law, okay, so if you were adding three numbers, you know that you can add these two numbers first and then add that number to it, or you can add these two numbers first and then add that to it, and you'd get the same answer. Yeah? And that happens to be true for vectors as well. Okay? So it doesn't matter how many vectors you're adding, you can add them in any order. Okay? And as long as you add them all together, you'll get the same answer. Okay? So the associative law also holds under addition. Okay? All right, so we already talked about subtraction. A minus B just means A plus of minus B, and you know what minus B means. Okay? So given a vector B, you can find minus B, and then just add that to A. Okay? So here it is in pictures. Here is A, here is B, and here is minus B. Okay, so you want to add A to minus B, so there is A, and there is minus B, and there is A minus B. Okay? We already mentioned this scalar multiplication. What does that mean? You're multiplying a vector by a scalar. Okay? So here is a scalar multiplying a vector. So if this was 2, you just get a vector twice as long, and so on. Okay? So 3A is a vector 3 times as long in the same direction. Now that's important, okay? Because now we're going to build towards adding vectors, doing algebra with vectors, doing vector addition and all algebraically, okay? Pictures are good to have in your head, but they're not good in practice to do calculations. So we want to see how we do calculations. All right, so we'll introduce 3 new friends, I, J, K. Okay, they're vectors along X, Y, and Z axes. Okay. So we'll introduce the Cartesian coordinate system. Okay. Now these guys have special properties. They have unit length. Okay, that means the length of that guy is 1 unit, the length of J is 1 unit, and the length of K is 1 unit. They have unit length and they are dimensionless. What does it mean by dimensionless?
They're just lines, they don't have a dimension.
Yeah, so what are the dimensions of velocity? Meters per second, length over time. What are the dimensions of acceleration? Meters per second squared. Length divided by time squared. Okay, so here's a velocity of 5I. Okay, so the 5 is what has the dimension. This is dimensionless. Okay, acceleration 5I meters per second squared. Okay, so I is always dimensionless. We'll use the same unit vector in representing velocities, forces, acceleration. It's the component that will carry the dimension. Okay, so that's what we mean by dimensionless. So we'll use those unit vectors to represent vectors with all different kinds of dimensions. Okay, the components will carry the dimensions. Okay, so I, J, K are special vectors. What are their properties? They're unit length and dimensionless. Okay? All right. All right, so now let's confine our attention to 2 dimensions. So we'll Okay, so let's understand what is this 5I? What is it? A scalar or a vector? It's a vector. Okay. I was a vector. It's in the x direction, and 5 times I is, this is a scalar multiplying a vector, which gives you a vector. Okay. And you guys know how to draw it. Okay, so I was in this direction, so 1, 2, 3, 4, 5. So there is 5I. Okay. All right. How about 6J? What is that?
Vector.
A vector. Okay. Again, J is a unit vector. J is a vector. 6 is a scalar multiplied by that. Okay. And now what we'll do is we'll add the two together. Okay. So what are we doing? We're adding this vector and that vector. And you guys know how to do it graphically. Okay. So let me draw 6J. Okay. So there's 1, 2, 3, 4, 5, 6. There is 6J. And what is the sum of these two vectors? It's this vector. Okay, we'll give it a name. We'll call it A. So, yep.
So the vector is just the direction, while the scalar is like how far it goes or how many units the vector goes?
Well, a vector, yeah, I mean, it has magnitude and direction, yeah. Ask your question again.
I said, is the vector just the direction while the scalar is like how many units it moves?
No, your speed is a scalar. How fast are you driving? Let's say 50 miles an hour. How many numbers did you need to specify that? Just one number. That's a scalar. Okay. Which direction are you traveling?
North.
Okay, so now that's another piece of information, right? Mm-hmm. All right. All right. So now you know how to write a vector using unit vectors. Okay. This guy, oops. This guy is called the x component of the vector. This guy is called the y component of the vector. Okay, so A is AXI plus AYJ. Okay. All right. Why are we inventing this technology? Here's why. Okay, so 5I plus 6J. And now that you're experts at this, here's another vector. Okay. All right. Now let's say we want to add the two vectors. Okay. So it's 5I plus 6J plus 3I plus 7J. Okay. And now the rules of addition are you add like components. Okay. So this would be, the sum would be 5 plus 3, 8I plus 13J. So that's how simple it is to add vectors. Okay. You guys understand? Everybody understand? Okay. Any questions on that? All right. All right, so let me introduce another vector, 2I plus 3J. Now, A plus B minus C. Okay, so let's do a slightly more complicated operation. Okay, so, but now it should be intuitively clear. Yep. And again, you just add up the like components. 5 plus 3, 8. 8 minus 2, 6. So the x component is 6i. And help me out with the y component. 10j. Okay. All right. So now, so you guys understand that? So, and would you be able to do this? 2a plus 3b minus 4c. Okay, let's try. Everybody understand how to do that? You want me to do that? Okay. All right, so now we've learned how to add vectors and subtract vectors. So, all right, so a vector can be written, you've learned how to write it in component form. This is the x component, there's the y component, and I, j are the unit vectors. Okay. And if you recall your trigonometric ratios, so here's a right angle triangle. This length is the hypotenuse times cosine theta. So AX is the hypotenuse times cosine theta. And the opposite side is the hypotenuse times sine theta. Yeah. AY is A sine theta. All right, so what's hidden here is the following fact. Now, in 2 dimensions, how many numbers do you need to specify the vector? 2 numbers. Okay. So, to specify this vector, you can either give AX, AY, these 2 numbers, or you could give these 2 numbers. Okay. That's the magnitude and the direction, or you could give the components. Or it turns out that you could give any 2 numbers. You could give, now this is not polite to do, but you could give these 2 numbers. Or you could give these 2 numbers. Okay, any 2 numbers. And you completely specify the vector in 2 dimensions. Okay? And of course, in n dimensions, you need n numbers and independent numbers to specify the vector. Okay. All right, so what these formulas are the following. Okay, so this is specifying the vector in English, let's say, and this is specifying the vector in Spanish. And what these formulae are if you're given these 2 numbers, how do you get these 2 numbers? And that's what. So given the magnitude and direction, here's how you get the components. Okay. And given the components, here's how you get the magnitude. And here's how you get the direction. So the direction will be tan inverse of AY over AX. Okay. Now here's something that you have to be careful about. Okay. So this is a multi-valued function. What does that mean? Tan inverse of a number can have 2 values. Okay. So what do I mean by that? Tan theta is equal to tan theta plus 180 degrees. Will give you the same number. Okay. And you can check this out in your calculator. So tan inverse of a number is either theta or theta plus 180 degrees. Okay. And you have to decide which is the correct solution. Okay, so if theta is the correct solution, or is this the correct solution, theta plus 180? Okay. But we'll get to that when we get to problems. Okay, so All right, again, in summary, in 2 dimensions, you can specify a vector by giving its x and y component or its magnitude and direction, or any combination of 2 numbers, okay? All right. Do you guys have any questions on this? Do y'all, yep?
So, according to the bottom 2 equations, we can kind of think as the magnitude as like the length and the directions of the angle.
Yeah, yeah.
Okay.
Mm-hmm. Okay. Okay, what this slide tells you is the following. Okay, so if you have a vector A is minus 5i plus 3j, okay, so what that tells you is, here's x, y, okay, I, remember I is a vector, I is the unit vector in the x, along the x-axis, and j is that vector. So minus 5i would be a vector along this direction, and 3j is a vector along that direction. So the signs of the components tell you what quadrant the vector is in. Okay, so this vector is in the 2nd quadrant. Okay, when both the components are negative, then the vector is in the 3rd quadrant. When the x component is positive, y component is negative, the vector is in the 4th quadrant. Okay. So this is telling you, it's relating the signs of the components and what quadrant the vector is in. Okay. Okay, so here on this slide, all we're showing you is, again, how to algebraically add vectors. You already know this. So here's A written in component forms. Here's B written in component form. And when you're adding them, you just add the corresponding components. Okay. So R is AX plus BX, and RY is AY plus BY. Okay. All right, now I'll generalize this. Let's make sure we understand this. So let's say A, B, and C are 3-dimensional vectors. Okay, so this, we'll call this sum R. And what is R going to be? 3AX plus 2BX minus 5CX. That's the X component. Can somebody help me out with the Y component?
3ay plus 2by minus 5c1 times j.
Somebody else with the Z component? Do you want to help me with the Z component? Okay, so anybody else?
3az plus 2bz.
I'm sorry? Okay. So now you know how to do algebra with vectors. Somebody, if somebody throws 1,000,000 vectors at you, you're not afraid anymore. Okay? You know how to add them, subtract them, and so on. Now we still have to learn how to multiply vectors. Okay? So we're going to go do that now. All right, now before we go on, so laws of physics are given as equations. So now here's another thing you want to learn. Okay, so in an equation, okay, so here's an equation, and let's say you have apples on the right-hand side. Can you have an equation with the oranges on the left-hand side? No. So if you have apples on the right-hand side, you have to have apples on the left-hand side. Okay, so here's an equation. This is a vector. How about this guy? This is a vector. T, that's a scalar. And that's a vector as well. A vector plus a vector is a vector. Okay. How about this guy? Half, what is a half?
Scalar.
It's a scalar. A, the acceleration, that's a vector. T, the T time is a scalar. T square is a scalar. Okay. That's a vector. So a vector plus a vector plus a vector is a vector. And that's equal to this vector. Okay. So now here's one test you can do about an equation, a law of physics. Okay. Again, laws of physics are given as equations generally. Okay. So you have to have similar terms on both sides of the equation. Okay. So is this a, could this be possibly a valid law?
No,
No. Why not?
because there's not a vector on this side.
Yeah, so you have vector on one side and you have a scalar on the other side. Okay, you don't have to know any physics. You don't have to spend $500 to know that this is wrong. Okay, all right. Now, here's a slightly more complicated object. Okay, so this is called a tensor. In 3 dimensions, vectors have 3 components. In 4 dimensions, it has 4 components. So in 4 dimensions, with time included, this has 16 components. Okay. Anyway, so this is Einstein's general theory of relativity. Okay, so here is a tensor which has 2 indices. Okay, so every term is a tensor. Okay. All right. Now here's another thing in the diagram here. Okay, so here is the vector. Okay, with reference to this coordinate system, that is the x component, there is the y component. For the same vector in this coordinate system, the components are different. Okay. So I'll write it in notation: axi plus ayj, ax prime, I prime, okay, different coordinate systems are like different languages. You're saying the same thing, okay, except that the components are different. Okay, all right, just be aware of that. Is the vector different? Is this vector different than that vector? No, they're the same. Okay. All right, I'll pause a second. If you guys have any questions, you can ask them now. Any questions? So we'll learn how to multiply vectors now. Okay?
Oh, okay.
Okay.
Could you go back a couple slides real quick? One more. You added 3 different vectors together on one of the slides. That one.
Mm-hmm.
So would you just add the 3ax with I guess I'm confused on how that's supposed to work, because I thought that you couldn't add a vector A with vector B like that.
What do you mean?
Well,
This is a vector, right?
yeah.
That's a vector, that's a vector.
So I guess I'm not sure how, like what the result is supposed to be, because you.
This is a vector. This is a vector, and vector. These are 3-dimensional vectors. Here's the x component of that vector. There's the y component of that vector. There's the z.
Okay, and that's as far as it goes. It doesn't simplify, right? Like that's it.
Yeah, that's it.
Okay, that's where I was confused. I thought we were supposed to
So,
simplify that somehow, and I
yeah.
didn't quite.
No, this is axi plus, I mean, I sprung this on you without giving an example before, but there's the x component of the vector, y component, z component.
Yeah. Okay. So that's just a multi-term x and y
Yeah.
and z.
Mhm.
That makes
That's a
sense.
vector in 3 dimensions. Okay. All right. Now, how many ways can you multiply numbers? Just one way. 3 times 4 is 12. Okay. It turns out that there's at least 2 ways you can multiply vectors, and you can define more ways if you want, if that's useful. But we'll show you how to multiply vectors 2 different ways. Okay. One is called a scalar product, and the name comes from the fact that the result is a scalar. Okay. So you're taking 2 vectors, multiplying them, and the answer is a scalar. Okay. Remember, in 3 dimensions, vector need 3 numbers to specify them. So you're taking 2 vectors, complicated objects, and coming up with a simpler product, a scalar. Okay. And then there's a second type of product, a vector product. And as the name suggests, you're going to take 2 vectors, multiply them, and the result will be a vector. Okay. And these will be useful for us later down the road. Okay. So let's do the products. Okay. The scalar product is also called a dot product because of the notation. The scalar product is written like so. Okay. A dot B. All right. So here's a vector A, here's a vector B. Okay. And there's the angle between them. Okay. So this angle is defined when you draw the vectors from the same point. Okay. And the scalar product is defined as the magnitude of A times the magnitude of B times cosine phi. Okay. This is a scalar, scalar, scalar. Okay. So that's a scalar. So you took 2 vectors, the input was 2 vectors, and the output was a scalar. Okay. Here's the scalar product written in terms of components. AX BX plus AY BY plus AZ BZ. Each is a scalar. Scalar plus scalar is a scalar, plus scalar is a scalar. Okay. So here's the scalar product written in terms of components. Here's the scalar product written in terms of the magnitude of the vectors. Okay. All right. One of the first places you'll use this is when you calculate the work done by a force. The work done by a force will be the force dotted with the displacement vector. Okay. So when you push on an object, if you apply a force like that, and that is the displacement of the object, the work done by this force on this object when you push it from here to there is that guy. Okay. All right, everybody understand that? So that's the scalar product. The second one is the vector product. Okay. And here's how we define the vector product. All right, so this is also sometimes called cross product because of the notation. It's written A cross B. The result is a vector. Okay. And here's, so this gives you the magnitude of the resultant vector. C is A B sine phi, where sine is the angle between the 2 vectors, A. So let's say here's A, here's B, phi. Okay. Now, so before I go into this, let me tell you the direction of C. Okay. So C is a vector, and it'll have a direction to it. Okay. So here is the direction. Okay. So if this vector is A, and this vector is B, all right. I guess I'm making a recording, so I gotta. Okay. So let's say this is X, Y, Z plane. Let's say the A vector is like that, and the B vectors. A vector is like that, B vector is like this. It's in the XY plane. The cross product A cross B is perpendicular to this plane. Okay, so A and B make a plane. A cross B is perpendicular to this plane. So C is perpendicular to the plane, so C could be in that direction or this direction. And here's how you figure out the direction. Okay, if you turn a screw from A to B, if you turn a screw like this, which way will the screw move? If you turn a screw from here to there, like that, it'll move up. Okay, and this is a right-hand screw, it'll move up. So that's the direction of C. Okay. If A were like this, B were like that, C would be in that direction. Okay. If A were here, B were like that, A cross B, it would go in that direction. That would be the direction of C. Okay. So you want to remember that. Okay. You will need to figure out directions of C when A and B. You'll do three-dimensional problems. If A is like that, B is like this, A cross B, C will be in that direction. Okay. So you turn from the first vector to the second vector, and that's the direction of the third vector. Okay, that's the direction of C. So that's your right-hand rule. Okay. All right. So here are the components of C. It's AY BZ, and I'll tell you more about it. AY BZ minus BY AZ I. So there's the X component. There's the Y component, AZ BX minus AX BZ, and I'll show you how to remember this, J, plus the Z component is AX BY minus AY BZ, okay, BX. All right, so it turns out that if you have done, how many of you know determinants? How many of you have done determinants? How many of you have done linear algebra yet? Okay. Hello there, my friend. Don't be on your phone. You gotta pay attention. Do you know this stuff?
No.
Okay. Now we know why you don't know this stuff.
Yeah.
Okay, so the cross product is written like so. Okay, it's that determinant. Okay. So here's how you do this. Okay, so A cross B, the X component is AY BZ, AY BZ minus BYAZ, you flip the components, plus the Y component is AZBX, AZBX minus AXBZ. The kth component, the Z component is AXBY, AXBY minus the switched components. Okay. Again, this appears complicated, but you'll use it enough times and you'll remember it. But it's that determinant. Okay. So here's a product. This is called a cross product. Okay. And it's different than this ordinary multiplication. What is 4 times 5? It's equal to 5 times 4, right? But it turns out that A cross B is not equal to B cross A. It's negative of B cross A. Okay, so it's a vector in the opposite direction. They have the same magnitude. So the cross product of two vectors is different than multiplying ordinary numbers. Okay? All right, so let me summarize what we've done so far. So in this chapter, what have you learned? You learned about a new mathematical quantity, vectors. Okay. Why did we learn about vectors? Why did we learn about vectors? Because somebody is forcing you to learn it?
They can contain both magnitude and direction
So-
in one variable.
Yep. So there are quantities in physics that are represented by vectors. Velocity, acceleration, force, those are quantities that all have magnitude and direction, and you represent them by vectors. Okay? And you'll need to learn how to add vectors. You'll need to learn how to add forces, velocities, and so on. You'll need how to take dot products and so on. Okay? So we learned about vectors. We learned how to add them, subtract them. We learned how to multiply them. Okay? And that was the chapter. All right, you earned yourself a 5